Welcome everyone to 3D Native's webinar, Revitalizing the Naval Industry with Elastomer Additive Manufacturing. Maria, could you just make it full screen, please? My name is Madeline Pryor, and I will be the moderator today. I am joined actually as well by our panelists, Vigelis Mavropoulos from Lino 3D and Lambros Liaskovitis from Hullworks SA. Apologies, gentlemen, for mispronouncing your names if I did, and good afternoon. So today, as I stated, my name is Madeline Pryor. I am the English content specialist for 3D Natives, which is the largest international online media platform on 3D printing, available in 5 languages, English, of course, but also French, German, Spanish, and Italian. I will be the moderator of this panel, especially the Q&A, and a reminder actually to all the participants, if you would like to ask any questions at any point during the webinar, please ask at the Q&A button, which you will see at the bottom of your screen. It just makes it much more likely that we will be able to see your questions at the end. And you can ask them at any point. We'll gather them, and we have 15 minutes dedicated entirely to the Q&A, so our experts will be able to answer anything you might want to know. And so moving on, Vigelis Mavropoulos, again, sorry, is the manager of the 3D department of Lino SA. He is certified with an MSc in electronic and mechatronic design. He has 24 years of experience in the medical and printing industry, having worked as a consultant engineer for De La Rue Imaging Techniques, developing banknote security features, and as vice president of sales at Smelter Group of companies. And for those of you who might not know, Lino 3D is actually a 3D printing lab located in Greece with an expertise in all kinds of additive manufacturing technologies. Their specialized personnel and fully equipped facilities manage to develop and distribute integrated printing solutions consisting of equipment, applications, consumables, and services to customers and professionals in the 3D printing market, focusing on innovative technologies and new materials. And actually just a little bit of a change, Kimon won't be joining us because he had something come up, but let me introduce you to Lambros Liaskovitis, who, following a successful career in banking as a private banker for reputable banks in Greece and Luxembourg, became an investment associated for a VC fund, and then decided to join the maritime industry in 2015. As marine activities had been lifetime hobbies of his. The first step for him was to be head of the marine division of Motor Dynamics SA, the exclusive distributor of Yamaha Motor for Greece, Bulgaria, and Romania for over 50 years. In the early years, Lambros, after graduating from Athens College, studied business economics at the University of Sunderland and received his MBA from the University of Strathclyde in Glasgow. And Hullworks is where he is currently working, as the sales and marketing director. Hullworks is a shipbuilding company also located in Greece, which is composed of professionals with diverse background and skills who combine their love of the sea and their skills to design and build seaworthy vessels and provide high-end boating services. So let's move on to the next slide and the webinar topic itself. So I'm sure most of you are very aware of the significant growth that we have seen in the 3D printing industry in recent years. What you might be less aware of is the actual growth of the elastomer market, which is also the material we'll be focusing on today. In this graph, which is from Polaris Market Research, you can see that though the elastomer market was valued at 172.1 million USD in 2020. It's actually expected to grow exponentially with a CAGR of 29%. As you can see, in 2028, it will have significantly increased, which is only in a few years. And that is actually in all areas, including North America, Europe, Asia Pacific, Latin America, and even the Middle East, showing the importance of elastomers in 3D printing. The reason for this is because demand for elastomers has grown as they have exceptionally good properties for different applications, notably high tear and abrasion resistance, durability, and elasticity. Though this growth might is more focused in automotive, aerospace, and defense and consumer goods, maritime is actually a sector that is rapidly integrating it and seeing the benefits of Elastomer AM, which you'll see more of later today. And if we can move to the next slide, please. So just quickly before I need to move on, the role of AM in maritime. Admittedly, maritime has been a little slower to adopt AM than some of the other sectors that are using the technology. However, that has been rapidly changing even over the past year. Many in the industry are starting to see the benefits of using 3D printing for various applications, for example, spare parts. One example I can think of, the US Navy is actually currently researching whether 3D printing could be used to create spare parts on the sea for their ships, meaning that they could carry lighter loads and have more availability for spare parts in case of any emergencies. It's also AM is particularly interesting for the sector, thanks to its flexibility, ability to create lighter, more optimized parts, and of course, its cost effectiveness. For those reasons, we are seeing increasing R&D in the field. Notably for today's webinar, companies like Lino and Hullworks are increasing the use of 3D printing in Greece, in the maritime sector, which is a major hub for maritime, as you can probably guess. And with that, I will leave you in the capable hands of our panelists. Once again, welcome everyone to today's webinar, and let's get started.
Thank you for joining us today. Let's discuss and to understand what is the elastomer and what are they. So an elastomer is a polymer with a property of elasticity, generally having notably low Young modulus and high yield strain compared with other materials. Elastomers are best described as rubbery materials. Rubber originally meant natural rubber. Later on, elastomer became to the word used to talk about synthetic rubber. Most rubbery materials are now considered a type of elastomeric material. Allow me here to emphasize that the production of elastomer with a traditional method, it's a time-consuming and expensive process. So today we'll explore how the 3D printing can offer unique production solution. So we have some elastomer examples. Probably let's focus on type of elastomers. It's a TPA, TPC, TPU, TPO, TPV, or TPS, and more. Some examples that is also familiar for us, all of us, is, let's say, shock absorbers, or gaskets, or impellers, connectors for sure, frame gaskets, pump ceilings, flexible couplings, even the plastic carpets in our house, they use an elastomer material. Let's focus on unique properties of elastomer. Which is the unique properties? First of all, elasticity or flexibility. Flexibility gives to elastomers a high tensile strength and also elongation and break. Plus, we have a tear resistant or abrasion resistant. And of course, oil or in some cases, any chemical resistance. Depends on the chemical. So all the above unique properties of elastomeric materials come to exploit with the use of 3D dimension printing. What is that? First of all, is the volume production without tooling and replacing the injection molding. This is the most important today. Of course, probably all of us, we know that with the 3D printing, we have a personalization and customization. Lower density of the part because we can design it to have a lower density. The weight of structure also, it's a matter of design that we can design with a such way to be a lighter, of course, on demand parts. And the most important for the service bureau services is the low material waste. For those who they are not so familiar with 3D technology, allow me to give a brief description of its technology. The oldest of one is the FDM, as we know, as a fused deposition modeling. The filament is passed through the hot nozzle and deposited in layers, creating the desired object. The other technology, who actually is new, is the name PAM, and it's a pellet additive manufacturer. In that case, the pellets or a flakes is extruded through the hot nozzle again and deposited in layers, creating also the desired object. The other technology that is also right now old is the SLA technology or stereolithography. Here we have a laser beam that cures photopolymer resin point to point till creating the desired object. And from the other hand, we have an SLS technology. This is selective laser sintering, that the laser beam fuses a photopolymer powder point to point again till creating the desired object. So 3D printing technologies for elastomer and DLP. So allow me once again to focus on what is the DLP technology. DLP technology is the digital micro mirror device, or DMD, which is the core of Texas Instruments DLP projection technology. The DLP chip contains several 100,000 micro mirrors, excuse me. The micro mirrors can be individually rotated in on or off position. In the on mode, the light from the LED projector is reflected by the lens, causing the photosensitive material to become solidified. So regarding the method bottom up, that we have a printers with a technology a bottom up, usually has been adapted to small printer for prototyping or for the small production for functional parts, of course, depending from printer or from the resin. So the top-down printing refer usually to the large capacity printers that usually use a DLP technology to take the advantage and benefits of this technology. Still, they use a photosensitive material, and we can see in next slides more deeply what is the top-down and what is offer the top-down DLP printing. Let's discuss a bit about the ETech or Envisiotech or E-Tech. The E-Tech was the first company in the world that to integrate DLP technology in 3D printing in the last 15 years. Based on this experience and know-how, led her to build the world's first production 3D printer that can handle elastomeric material. The extreme 8K printer can produce hydrants for functional parts of different size and shapes, taking the advantage of benefits that only 3D printing can offer. The goal of this machine, of course, is a large production scale 3D printing with a volume of 66 liters of resin. Here we can see some parts which can be made of elastomer material. I will focus on the impeller, is the white one on the top row. Perhaps is the most important component in both engines. The purpose of the impeller is to cool the boat engine by transporting seawater in the engine. That means this part can be stay and operate in a very, very harsh environment. Right now, if someone wants to produce all these parts, should be invest a lot of money to produce a mold and to time to wait, I don't know how many months to produce the mold and then to starting to produce part by part or one part. With a 3D printing, we can print it on demand, just one part. So, elastomer. Industries of elastomer. Industries of using elastomer, it's more or less everywhere. Is a construction industry, oil and gas industry, coating industry, consumer goods industry, sports, automobile, medical, electrical. If we see around, you can see in our house or in our office, you can see many, many elastic material or elastomer material. In that case, in this presentation, we will focus on marine industry. Let's discuss, first of all, just a bit from our area in Greece. In Greece, we have more than 5,000 islands. And maritime market is a larger industry, and we have many small and large shipyards. Elastomer they can take all this advantage, like rapid manufacturing, customization, design, follow data, material and running aging, abrasion and tear resistant, or in demand products, and to try to adapt on marine industry. That's why we decided to work with one of the best shipyards in construction of luxury inflatable boats, Halworks. We asked them to suggest us some of the parts that are made of elastic material and that they believe will help them in their production. They choose to print not a luxury or fancy accessory that Halworks usually puts on their boats, but they choose those that are constantly in harsh environment and in contact with the salt water. Some of these will be presented by Halworks executives, my friend Labros, in the next slide.
So, hello and welcome from my side too. Thank you, Vangelis, for the nice presentation so far. Let me tell you very quickly that we build our boats out of GRP. That is glass reinforced polyester, if you haven't come across it. So GRP is the core material of the boat. However, once the hull and deck are built and glued together, we start installing other parts, whether that is the console or smaller parts like handle parts, like other parts. As you see here, a deck drain. What a deck drain does is just a hole on the boat, on the deck of the boat, which allows for all the water that might come in from, let's say, a large wave, or while, I don't know, cleaning the boat or whatever. So the deck gets to drain. That's why we need an outlet like the one you see here. So that's at the back part of the deck. As the water comes in, it flows to the back of the deck and then out of the boat through this drain. The material we were using so far was out of stainless steel. Why? Because obviously it's easy to make and design, and easy to install in a place where there's a lot of salt water, as stainless steel is quite durable in terms of corrosion. However, there's so many limitations in using stainless steel. That's why we started thinking about what other materials we could use, which will be sustainable, because we don't want to pollute the environment anymore, which will be durable, which will have all the properties that we need to make sure, first and foremost, that the deck drains, and then obviously that we don't have to replace it every now and then. We don't have our customers coming back and saying, you know, it's all good, but there are small parts that we don't like. That's how we came across Lino 3D and asked them to produce this little piece for us. So now all of the parts that can be 3D printed with elastomers are fully customizable. They're quite quick in manufacturing, and we are sure that we won't get any issues with the salt water, which, as you know, kills everything in terms of materials. I'm speaking, of course. As you can see here on both pictures, we're practically talking about two parts. The first part, which has a rectangular shape, is what you see on the deck, and then behind it is what we will see on the next slide, or the one after, in fact, which is the valve. So let's move on to the next part, and then we will come back to the deck drain. Maria, please. Vangelis, can you explain a little bit about the material we use for the raw material that we use?
So yeah, in that case, we're using adaptive 3D elastic tough rubber with a SOR 70 in order to produce the part. Characteristic of the material you can see over here, and of course you are using an Extreme 8K printer. Next slide, Maria.
So
Excuse me?
Yeah, I was saying there are different types of raw materials, there are different hardnesses.
Of course.
The one we chose for this application, that's the most suitable one.
Yes, of course, of course.
Okay, let's move on, if we may. That's another small piece that it was troubling us a lot. It's a simple thing. It's a knob to a small hatch. Clearly, this knob doesn't turn. You just use it to pull out the hatch. So it's nothing really fancy. However, when you build custom boats, it's nice to have small parts with your logo, or make it even more personal for the customer if he wishes to. So on the left picture, on the picture on the left, you can see that we're using both plastic and stainless steel. What it means is two suppliers, then someone at the boatyard who will bring these two pieces together, create the knob then, and install it on the hatch. Clearly, an easy solution would be to have the knob ready, skip the part of assembling the knob and moving on to installing it on the boat. That's as we did again with Lino 3D. We recreated the knob, the design of the knob, and had it printed using elastomers. So now it's even more durable than the previous one. There is no stainless steel part which may or may not come off at any point, or it may corrode, or anything like that. So each personal is customizable. It's easy and fast to produce.
Labros, how many knobs you have in your small boat, not the big one? Roughly.
Well, for this specific hatch, there's 2 knobs on every boat, and we build 40 boats a year, so we're talking 80 knobs.
Okay.
All in all, and of course, we as we come up with new designs and new hatches, we may even use it further on another part of the boat, so they can multiply easily.
Okay. Okay. In that.
Imagine, sorry to interrupt, Angelis, just imagine the situation where you get 80 plastic pieces of this knob, and then another 80 stainless steel parts, as you see them, they're laser cut, and then you have to put them all together, glue them together, and then install them on the boat. We're talking about a week's work for someone, which is a complete waste of time.
Only for 18 pieces, eh?
Just for making one knob, and there are many more pieces on the boat. There are many more handlebars, many more latches, many more. I cannot even begin to list them. There are way too many. Let's move on a little bit, and
next page, Maria.
If there are any questions, we can come back to that as well.
So for the knob, we used a harder material with a Shore 90. Characteristics of what we can see also over here. Still, we use the same machine, Extreme 8K. If you want to swap material in this machine, it is, let's say, easy, and we are able to, let's say, to choose a different material depend of request of our customer. Labros.
So this is the latter part of the deck drain we were looking at earlier. What this piece does is it is added to the rear of the deck drain we saw, and it's just a simple one-way valve that allows the water to come out, but not back in again. It's quite simple as a solution, yet really super important because you never want the water coming into your boat. So what we managed to do through 3D printing is obviously to improve the design, because there are limitations to what you can do with stainless steel, and then attaching parts to it, because the little piece you see, the lighter color, almost white, it's always plastic. It's always from an elastomer or some material of this kind. It can never be stainless steel.
Silicone.
So, silicone, yeah. So you always have to make sure that you attach it properly to the stainless steel rubber tube that you see there. So doing that to an elastomeric tube is quite easier. The materials come together more nicely, and then it's also a matter of corrosion, like we discussed earlier. You never want metals corroding on your boat. Why? Because especially in this part, salt water is always present, in the sense that it comes backward and forward, and there's always a little bit of salt water left there. So corrosion will be instant if you don't use the proper materials. And that sort of elastomer is our best case now.
That's why it's the most challenge part that you are giving to us is this, Labros, and indeed, let's say we are thinking seriously which material we will use, and finally we decided to use an elastomer, and we are right. We'll make a good decision, and will be, let's say, present in your boats for I don't know how many years.
Yep.
Without
that's true. That's true. You know, making the easy parts is always simple, like a simple handlebar or a simple I don't know, thing that is just going to be decorative, like a cup holder or something like that. That's easy. What is difficult and needs engineering is getting to this stuff, which is of importance to a properly floating boat and safe boat, of course.
Of course.
That's pretty much it about the parts we did so far. We have more and more lined up, testing all the time and going back and forth until we reach a final design and of course a final production method that is beneficial to everyone involved. So yeah, that's pretty much it.
And of course, we have for you also the parts that are not included on this presentation. That is a shock absorber of the engine, plus some.
Okay, nice.
Also, plus some customized key ring with a name of the lucky owner, new owner of the boats.
Well, if we have a minute to spare, I'd like to talk about that. It's always an issue with key rings on boats, on open boats up to 10, 12 meters, where you are in contact with the water. It's not a yacht, but it's not a keyless boat anyway. So you have to have your keys attached to something, preferably something that floats, but it definitely has to be good looking. Why? Because as you get off the boat and onto a little harbor or a beach or anything, you have it with you. So we needed something custom, and there was no way we could find something good looking and with the right properties. They won't be, it won't polymerize with the sun. It won't be affected by salt water. And nothing out of these foam materials or any of these used so far are good looking or can be shaped into nicer shapes rather than round, rectangular, or simple shapes. So that was the idea we had, is to have our in-house designer design a key fob, sort of a car-like key fob, and then asked Vangelis if he could 3D print it. And of course, make it personal again by adding, leaving a small space where we can add the name of the boat or whatever our customer decides to have it marked as. So I'm really, really curious to see that in the coming days. I saw the 3D design. I was part of it, but having the real thing in your hands is what I'm after now.
I hope we'll be able to present it in the next webinar.
That'll be nice.
To see the people more challenge and the more fancy or luxury parts, not only functional.
Not only hardcore engineering. Yes.
Hardcore engineering. Correct.
Make it more fancy too.
Yeah. Let's focus on the next step, on the fancy parts, not on the.
Next time that will be it. So I think there's another slide with the properties of this material we use here.
I thought it's the material. We choose a 90 shore, more harder also this material. We want to be totally follow your specification, that you gave to us about the one-way valve and how to react with the water and all these things. I thought pass this test and we are happy. Both of us were happy, I thought.
Yep.
Next slide, Maria. So thank you very much.
Yes, thank you. Yes, well, please.
No, please. It's you, Madeline.
Well, I was just going to say thank you to both of you for the panel. As I mentioned before, well, we're a little early, but we will open the floor up to questions. I see that there are already some. I'm actually just going to ask the two that are in the chat right now, so I don't lose them already. But feel free to ask questions, as we mentioned, in the Q&A, and also vote for which questions you would like answered. So I am going to start with the questions from Delphina. First, which is, why do you think that the maritime industry has taken longer to embrace AM?
Excuse me to see.
That's probably for me to answer, I guess.
Yeah.
Why? Because it depends. I mean, for us, building smaller boats, like I said earlier, 10 to 12 meters maximum, no one is really interested in new technologies. They know a way that works and they stick with it for as long as they can. Why? Simply because our production capacities are small. Like I said, we produce 40 boats a year. Some other Greek boatyards produce up to 50, 55, maybe even 60 boats a year. So R&D in general is quite focused on making the boat look better or even make the hull faster, rather than using new technologies for smaller parts. So I think, small production, small sector, not too much R&D because of simply lack of resources.
I think it also probably makes sense. It's one of the most ancient of the sectors we have, that they'd continue doing what they've always done. There's always room for more innovation. And then the next question, which is, would you say that DLP, so digital light processing, is the most common technology used in maritime? If I know that you both use it, but
let me answer. No, I thought this has to do with Envisiotech, or excuse me, ETech, that has collaborated with experts on the fields that can produce a very, very special material, end-use material, that they are not aged during exposure, sunlight, or in harsh environment. It's a matter of, let's say, know-how of ETech and experts of the companies that they are collaborate.
That makes sense. Okay, thank you. And now I will move into the Q&A. I believe we should have time to answer all of them, but feel free to keep adding them. And also, as you can see on the screen, if for some reason your questions are not answered, do feel free to contact either Vigelis at Lino or Lampros at Hullworks, and they can answer your questions later on.
Okay.
So just moving into the first question, what is the cost of production of the knob compared to the conventional one with a laser cutter?
Of course, first of all, depends on the quantity. But for sure, the cost probably will be half.
Yeah, that was I was going to say. The conventional one with PVC and stainless steel is probably double.
Yeah.
What we're 3D printing. Yeah.
I mean, that's a significant difference.
Then and that does not include the labor cost for assembling it, putting together the plastic part and the stainless steel on it.
Okay, so actually quite significant savings, which, well, that's what we kind of expect with AM, but always interesting to hear. And then actually another question about a part for either one of you is, if you retain the silicone's flap in your printed elastomer one-way valve, is that because there is no satisfactory printed material that satisfies the requirements of both flap and valve housing? So basically, why retain the silicone flap?
That's too technical for me, Vangelis, if you can.
Though it's also possible to print with silicone, depending
no,
on what you're using.
It's not possible to print the silicone. I'm trying to understand, let's say, to give to him a proper question. No, it's not. Actually, the reason that we choose this material, it's on the original, there is two different materials. One is the stainless steel, the second is the silicone, and the third is the screws. With this way, that's what we designed and we choose this material, we believe that it's better, and it's more safe, and this is my question.
Okay. No, okay, so it's safer, so that's the reason why you keep it.
Yeah.
That
So,
makes sense.
No,
Yes.
I'm okay.
Okay, well, thank you. That does make sense. And moving on, another question is, what is the difference of using DLP versus SLS by meaning of elasticity in percentages? And can you give a budget cost? It says of this part, but I'm not sure which part he is referring to. But if you could explain.
DLP is actually, it's a matter how you slice the part. With the DLP technology, you are printing one layer at once. That means you slice your file and you project a whole image on built-in area. On the SLS technology, you are just printing point to point. The quality of the DLP, it's comparing the SLS is the day and night. That means with SLS technology, with the DLP technology, you are not able to see the lines. And when I say DLP technology, I mean Envisotech or E-Tech technology. You cannot see the lines of separation. From the other hand, SLS, the part is not so, let's say, need to be, when you print it, need to be finishing when you finish the part. Regarding the cost, did they mention the cost or not?
They asked about the cost, though I'm not sure for which part they were referring.
Me also. I will say about cost of the DLP. I thought it's much cheaper due to the production time comparing the SLS technology. DLP, it's 10 times faster than, at least, than SLS technology.
Okay, yeah, it's a significant benefit of using the technology, I'd say. Okay, well, thank you. And then moving on, So the next question, which just suddenly got more upvotes, is how does the AM deck drain compare to the steel deck drain in regards to manufacturing cost, production time, and possible reduction of parts?
Again, production cost, I would say, should be half, roughly. And then production time, I think it's way faster. I don't have exact times to put, but It's so much faster. Vangelis, what do you think?
And assembly also.
Yeah,
I mean,
assembly is also
faster.
faster.
Yeah. It's faster.
But they don't have exact times. I don't know if one thing takes 1 hour, then how long the printer takes to print it, and I don't know.
Oh.
But yeah, it's definitely faster.
Comparing the original one that is on the left side and the additive manufacturing on the right side, it's a night and day also. The left side are produced, I don't know how many ways. With you should take the metal, glue it, iron it. It's, I don't know. It needs days to produce this. With additive manufacturing, hours.
Exactly. It's a lot faster. And then Stefan is also asking production and possible reduction of parts. Yes, reduction of parts in the sense that the 3D printed part is one part, whereas the stainless steel is a few of them glued together. So yes.
Of course. So also
not for us, it's in terms of production of the parts. This has nothing to do with us. We receive one part in both cases. So but yes, production wise, yes, for whoever produces this part.
Also, KT asked about, can the elastomer be available in shore 11 or 45? Question is, even if I am not qualified to ask to give you a question to answer you, but I thought in the near future will be available a lot of different shore material for elastomer.
Okay, and actually another question from Katie, which is there any shrinkage in the final product?
Of course not.
Okay, and then
of course not. Actually, what is the 3D printing and also the DLP technology? Nothing to do with the sintering or with no, SLA is also the same. Actually, it's a sintering. We're not sinter the parts. We're design the CAD files, we slice it, we send the machine, and we print it one by one. There is a factor, shrinkage factor, but usually during slicing and before we send it to the machine, we know exactly the shrinkage of material, if any, and the final parts are corrected. Just imagine that the same machine, smaller or bigger machine from an Visotech or E-Tech, they offer dental or medical applications. That means should be very, 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 very accurate by using exactly the same technology.
Okay, well, we'll be looking forward to seeing that. So we have about 6 minutes and we have about 3 questions. I think we have enough time to get to all of them. So the first one that I noticed was, well, I'm assuming it's for you, Lampros, actually. It's, are you seeing greater adoption of the technology, AM, in shipyards, and what do you expect to see in the coming years?
Oh, of course. Of course. General speaking, from additive manufacturing, yes. Yes is the future. Yes is the future. We have many requests with open mind companies like Halworks that push us to show them final functional 3D parts, not only from plastic, because we offer also metal, ceramic, a lot of material in our lab. And we have, let's say, many, many requests from different kinds of materials. And we hope, or we are sure, in the near future, maritime industry or shipyards will be, let's say, moved totally on 3D printing.
Thank you. Well, I mean, I agree, but this is also my industry, so I might be biased. And then another question is, where do you see the most added value for AM in the maritime sector?
Oh, first of all, production time.
Okay.
And sometimes cost. If we are focused on the
Yes.
mold, or if we focus in the mold industry, excuse me, Labros, excuse me.
No.
If we are focused on the mold industry and discuss not only from elastomer material, are general speaking from 3D printing, the mold industry is the biggest and most expensive part of shipping yards or maritime industry. They invest a lot of money and they're waiting months. With a 3D printing, the months come at days, and the price are more or less also half. But the goal is delivery time, days, not months. 2 days, 3 days, week, not 2 months, 3 months, or 5 months. Just a week. Is additional resistant to harsh environment, or there are other major requirements or regulation required of material for maritime usage?
Yes, that would be the next question. So just so I can read it, just in case anyone hasn't seen it, in addition to the resistance to the harsh environments, are there other major requirements and regulations required for materials for maritime usage?
No, at the moment, there are no specific regulations. Unfortunately, what we do and boat building in general is not so green. If I understand the question correctly, it has to do. No, I'm sorry, I reread it.
It's a regulation.
We're talking about harsh environments in terms of sun and salt water and something like that. Yes.
And requirements, you know, like you'd have an aviation for that if there are similar requirements beyond that in maritime, is how I understood.
Yes, well, obviously, there are no specific regulations. But imagine that every boat builder, for example, puts his signature down to the fact that the boat will drain from the water coming in, and that the boat will be structurally sound. So it's not only a matter of regulations. It's how you feel of working on something that will actually carry people on the water. So it's both a matter of regulations and an ethical issue as well. So yeah, if we can start using materials that are more durable, and we can be sure that there won't be any issues with them also further in time that we can say about stainless steel or the materials we use so far, then I think it's a win-win for everyone. It's not just about cost. We just keep mentioning cost, and it came up in a lot of questions, but it's not always about cost.
No, of course, safety is always very important, durability, other factors. Well, that was the final question, and perfect timing actually, because it is just hit 5 p.m. CST. So with that, I will say thank you, both of you, for attending today. It was a pleasure having you both. We hope to see you at the next webinar. Have a great evening, day, depending on where you are.